Hi there, and welcome to Geology. This is very first lecture about the geology. My name is Engineer Abid Ali, and the course code for this subject is GS-119. And this lecture is made by the HOD of our Civil Department, Professor Dr. Sher Afzal Khan. So let's start. The course objective include that it will provide you with the background to geological first principles, allow you to make educated decisions about geological problems, foundation for engineering geology at higher level where more applied aspects of subject presented, theoretical but applied aspects too. This is basically the course outline of our subject, in which we have introduction to geology and mineralogy, rock classification and geological names of the rock, geological phenomena, description of rock masses and thickly bedded or thinly bedded, glacier and glaciations, seismic theories and earthquake histories, seismic waves and earthquake measurements, volcanoes and ground motion parameters. The structure of course is that it includes lectures which will provided to you later, notes you guys have to take during the class. Assessments would be like the 25% will be the midterm examination, 50% will be the final term examinations, and 25% is basically the sessional marks, in which we quizzes, assignments, home work presentations are included. So if there's any assignment that have given to you guys, so copying and plagiarism is strictly not allowed, and penalties for the late submission or in university according to the university guidelines. So at the end of this lecture, you guys will be know what geology is and relate the importance of geology to the civil engineering, and the rest is basically in the lecture number 2, which will be discussed inshallah in the next lecture. Okay, as I have said, this is lectures, 2 lectures per week, which will be 1.5 hours. Tutorial that will be provided to you later separately, which will be of 1 hour. These are different suggested primary texts, in which we have name of the author, year publication, title of the book, edition, publisher's name, and ISBN number. You guys can have look at them, and there are different types of books for the geology and seismology. Okay, in geology, this is basically the science of the earth history, in which we study about the composition and structure and the associated processes, draws upon the chemistry, sustained biology, physics, astronomy and mathematics. In mathematics we notably focus on the statistics. So branches of geology, basically we divide the branches of geology basically into 2 categories, that is the physical and historical geology. In physical we have subcategories like mineralogy. This is basically about the study of chemical composition and structure of minerals. Petrology, the study and composition and origin of rocks. Geomorphology, the study and origin of landform and their modification dynamic processes. Geochemistry, the study of chemical composition of earth material and the chemical changes that occur within the earth and its surface. So geophysics, as geo means earth, so the behavior of rock material in response to stresses and according to the principles of physics. Sedimentology, the science of the erosion and deposition of the rock particles by wind, water or ice. And structural geology, the study the forces that deform the earth rocks and description and mapping of deformed rock bodies. And economic geology, this is about the study of exploration and recovery of natural resources. These are such as like ores and petroleum. And the engineering geology, in which we will be focused on, so it is about the study of interaction of the earth crust and human-made structures such as tunnel, mine, dam, bridges and building foundations. And the spectral geology, in which we study about the analysis and portion of electromagnetic spectrum to identify spectrally distinct and physically significant features of different rock types and surface material, their mineralogy and their alternation signatures. So that was all about the physical geology. Now the other second category is historical geology. As you can see from the heading, historical, the history, this related to the history, in which which is all about the in the past. So a historical study deals with the historical development of the earth from the study of its rock. They are analyzed to determine their structure, composition, and interrelationship, and are examined for remain of past life. This include the paleontology, the systematic study of past life form like stratigraphy, layers of rock and their interrelationship, paleogeography of the location and the ancient of land mass and their boundaries, and geological mapping, the superimposing of geologic information about existing topographic map. Historical geologists divide all the times the formation of the earliest known, that is like 4 billion years ago, into four major divisions, that is Precambrian, Paleozoic, Mesozoic, and Cenozoic eras. Each except the Cenozoic ended with profound changes in the deposition of the earth, continents, and mountain, and that was characterized by the emergence of new forms of life. Well, basically the main difference between the physical geology and the historical geology is that the physical is like studying about the present and discussing about the present, like what we are seeing now these days, while the historical geology is basically is this like the studying the origins, like from the past, the studying the history of the earth, like from where all these things, the rock formations, the water, from where the earth are came from. Geology is being called upon to guide civil engineers in planning buildings, highways, dams, harbors, and canals. This is basically we are talking about the importance of geology in the field of civil engineering. Geologists help us to recognize how devastation caused by natural hazards such as the earthquakes, landslides, floods, beach erosion, and can be avoided or mitigated. So all these earth material, including which is water, soil, mineral, fossil fuel, and building material, are geologic and are discovered, exploited, and managed with the aid of geologic science. These are the different pictures in which you can see as the role of geologists and in the field of civil engineering. Okay, the earth outermost layer. What are the earth outermost layer? Basically we divide this into three. That one is atmosphere, the second one is the hydrosphere, and the third one is biosphere. Atmosphere, as you all guys are familiar with, this atmosphere is basically the small fraction of the planet's mass, that is less than 0.01%, and which we have the nitrogen and oxygen 78% to 21%, while the 1% we have the other gases. So the second one is hydrosphere. Hydro is like meaning of water. So hydrosphere is the total mass of the water on the surface of our planet. Water covers up about 71% of the surface, and which in this 71%, 98% is the ocean, while 2% is in stream, lakes, and groundwater and glaciers. The third one is biosphere. Biosphere is the part of the earth where life exists, which where we are include the forest, grassland, and familiar animals of the land, together the numerous creatures that inhabit the sea and atmosphere. And in the below pictures, as you can see, the differentiation between the biosphere, the atmosphere, and the hydrosphere. I think these three are clear to you. Okay, let's talk about the geology. What is geology? Define geology. What do you mean by geology? This is basically the study of planet Earth, focusing on rocky interior and processes. As you can look at the word geology, geo means earth, while the logy is basically the logic. So it is all about the earth's logic. Okay, in this picture, this is basically the interior of this is basically. Okay, now these are the different layers of earth, in which we have the top is the crust, and below that is the upper mantle, lower mantle or mantle, outer core, and inner core. And also we have different types of atmosphere layers as well. The first one is exosphere, thermosphere, mesosphere, stratosphere, and troposphere. Okay, What the physical properties include, we have like compositional layers that are the crust, mantle, core, as we have talked about that earlier, and the other is like the mechanical layer, in which we have the first is lithosphere, which is from 0 to 100 kilometers, and that is basically rigid in nature. The other one is asthenosphere, which is 100 to 350 kilometer, and that is soft in nature. The third one is mesosphere, outer core, that is 2900 to 5100 kilometer, and that is in nature is in liquid, or you can say like semi-solid. And the last one is the inner core, in which we have like the distance is like from 5100 to 6370 kilometer, and that is in nature is in solid. The layers of earth, basically we divided that into three, as we have discussed earlier: the crust, mantle, and the core. While the crust thickness is between the average of 5 km under the ocean and 31 km under the continent, it is composed of various kinds of solid rock and sits upon the mantle, the earth middle layer. While the mantle is about 2900 kilometers thick, it is made up of primarily of silicate rock at temperature that varies between 1000 degrees centigrade nearest the crust and 5000 degrees centigrade in the deepest region. At these temperatures, the rock has a little strength and can flow very slowly, centimeters per year, like a very viscous liquid. The innermost layer, the core, has a radius about 3480 kilometers, and that is made up of primarily of iron and nickel. It has two distance layers as well. The outer one is liquid, the inner is a rigid mass of superhot iron that spins faster than the rest of the earth around its axis. It is believed that the whirlpool-like currents in the outer core gives rise to the to the earth magnetic field. Okay, this is basically the figure in which you can see the core, which we have the lower mantle, and above that is the upper mantle, and then we have our crust, and the distance of these from these layers from one to another. And in the top we have the continental crust, the asthenosphere, lithosphere, and the oceanic crust. The composition of earth: depth from surface in kilometer, temperature scale in degrees. This figure shows basically the distance of layers from each other. Okay, these are basically the outermost layer of the solid earth, which is basically based on the physical characteristics, and that are asthenosphere and the lithosphere. As you can see, the asthenosphere is very hot and its melting point and is capable of plastic flow, while the lithosphere above its cooler and enriched. It includes the uppermost part of the mantle and two types of crust: thin, dense oceanic crust, and thick beyond continental crust. And this figure, as you can see, is if we come 60 kilometers down, that is all we have is lithosphere, and below the lithosphere we have the asthenosphere. These are the oceanic ridges, the folded mountain belts, stable platform, and this is called shield. These are basically continental crust, which we have is like 70 kilometers. Okay, about the layers of earth, so it is important to note that there has been so far no drill that has penetrated the surface of the earth more than a few kilometers. Almost all information about the internal surface of the earth is inferred from observed characteristics and propagation of the seismic waves. The magnetic and gravitational observation can also help complete the picture. About the seismic waves, what is seismic wave? We will discuss that after the midterm. Okay. So the earth is divided into three main layers, as these layers are discussed earlier: core, inner core, outer core, mantle, upper mantle, and crust. So the core is composed of mostly of iron and is so hot that the outer core is molten with about 10% sulfur. The inner core is under such extreme pressure that it remains solid. So most of the earth mass is in the mantle, which is composed of iron, magnesium, aluminium, silicon, and oxygen silicate compounds, and over 100 degrees centigrade the mantle is so solid but can deform slowly in plastic manner. This is another picture in which you can see the different layers of earth. The center in this one we have is the core, which is solid in nature, and above that we have the outer core, which is liquid in nature, and above the outer core you can see we have the mantle, the upper mantle, and then we have the crust. These are basically the different layers of the asthenosphere, lithosphere, and mesosphere. Mesosphere is basically in the upper mantle. So the mesosphere basically hot but stronger due to the high pressure, while the asthenosphere is hot and liquid, weak and plastic in nature, and while the lithosphere, that is the cool, rigid, and brittle, which is basically our surface of the earth. The crust is much thinner than any of other layers and composed of the least dense calcium and sodium aluminum silicate minerals. Being relatively cold, the crust is rocky and brittle, so it can fracture in earthquake. The shell of the earth, the crust, can be said to have two different of thicknesses. Under the ocean is relatively thin. It varies in thickness from 5 to 8 kilometers. Under the land masses, so it is relatively thick. The thickness of the continental crust varies from 10 to 65 kilometers. What is homogeneity and heterogeneity? Often assume homogeneity for calculation. Nature is not homogeneous but heterogeneous. What is homogeneous? Which are same in nature. So nature is basically not homogeneous, it is heterogeneous, difference from each other. Geology and geological process help us to understand the heterogeneity and design accordingly. What skills do we need to study geology? There are basically two critical skills: to think in 4 dimensions, 3D and time, and to be able to think on a range of scales. Otherwise, use same scientific principles, use common sense and everyday observation. So as you can see, there is a small note: to control the nature, we must first understand it. Okay guys, that would be all of the lecture 1. Thank you. If you guys have any question, feel free to ask. Thank you so much.